Hello, I would like to spend a couple of minutes just reviewing some of the humidity concepts and trying to use some concrete examples here to bring these home. I haven't written out this transcript, so it'll be a little bit on the fly. Okay, first let's try this, more about humidity. We've all experienced this. I have two glasses of fluid, one with some ice cubes in it and one that does not have any ice cubes. We can probably say it's at room temperature. And usually our experience with this is that the outside of the glass will have condensation on it. It'll be dewy, it'll be wet. And another way to look at this is that it's saturated right at the interface between the cold glass and the atmosphere. So let's look at some of the variables that are at play here. So we measure the temperature, we measure the dew point, we measure the water vapor content of the air, and we calculate the relative humidity as a percent by taking the actual amount of the water vapor, whether it's measured in the mixing ratio or vapor pressure, divided by the capacity of the air at that temperature. So, just to review, we measure temperature using a thermometer. We measure dew point temperature. One way is by using a wet bulb and a dry bulb and looking at the difference, and then using a chart to calculate the dew point. We can get vapor content, water vapor content, using a graph. Here is temperature versus water vapor pressure. And notice that as you decrease temperature, the vapor pressure, or the amount of water, also decreases. So warm air has a higher vapor pressure, water vapor pressure, than colder air. That's very important. And then, as I mentioned before, we calculate relative humidity by the actual amount of the water vapor divided by the capacity of the air at that temperature. Look at what we have here. So, for the for this glass here, the temperature is cold, or it's a low temperature, and over here it's relatively warm, or a higher temperature. The dew point temperature, the temperature at which condensation occurs in the air, is the same, but not at the glass-air interface. The water vapor content for the air is the same. Okay, that doesn't change. So that means something else has to change. The relative humidity changes. Okay, so the relative humidity at the glass surface is high. Okay, because the capacity is lower because of the lower temperature. And whereas at the warmer glass, the capacity is greater, so the relative humidity is lower. So this means that at higher relative humidity, we get condensation. Another way to look at that is the dew point and the temperature for this glass are closer together than they are for this. So therefore you have a higher relative humidity. So let's look at another example. This is the Arctic polar situation versus the desert 30-degree latitude environment. Okay, let's go through the different characteristics: temperatures, cold, warm, or hot. In the deserts, the dew point temperatures, in this case, we're going to be a little different. We're going to say they're near the air temperature, and here they're far away from the air temperature. The water vapor content, okay, is lower than the desert. Okay, so there's more water at the pole, and that is shown in this graph. This is from the reading. We have latitude versus specific humidity, which is a measure of the amount of water vapor in the air. So here's 30 degrees latitude, where all our deserts. It has a specific humidity of around 10.7 or so grams per kilogram. And when we go to higher latitudes, notice we have a lower specific humidity, around 5.5 to 5.75. The key point here is that the deserts have higher specific humidity, higher water vapor content than poles. So why does it feel so dry here? So the answer to this conundrum, as outlined in our our concept map, is shown here. So cold, near air temperature, the water content's very low. Okay, so we have a high relative humidity. Okay, there's a relatively small capacity because of cold temperatures, and there's actually a relatively small amount of water vapor. So that makes for a high capacity, a high relative humidity, sometimes near 100%. Okay, so even though these areas feel super dry to us, these um, have lower water contents but higher relative humidity. So now if we go over to the deserts, hot, there's a great difference between the air temperature and the dew point temperature because we're at 30 degrees latitude. The water vapor content's higher. Okay, this is the curious thing. There's more water vapor at this area than the polar areas, but it has a low relative humidity because it has such a high capacity to hold water vapor because it's very hot there. So that inverse relationship is kind of stifling, and I think some people have really struggled with that, and I hope this helps out a little bit. Thanks.